Iron, nickel, and cobalt are metals that a magnet attracts. Steel is made with iron. So is a magnet. Attracts paper clips, staples, and food cans made of steel. A magnet does not attract plastic, wood, or rubber. You can also observe whether a substance dissolves in water. To dissolve means to mix evenly in a liquid. When a material dissolves, it breaks down into tiny pieces that seem to disappear. Both sugar and salt may dissolve in water. Many substances do not dissolve in water. If you stir sand in water, the sand does not dissolve. Metals, such as copper, silver, and stainless steel, do not dissolve in water. Suppose you use a stainless steel spoon to stir sugar into a cup of tea. The sugar will dissolve, but the spoon will not, which is probably a good thing, right? Because if we had everything that dissolved, then we would have metal tea and metal coffee, or plastic tea and plastic coffee. Okay? You can observe whether a magnet blanks a substance. What is the magnet going to do? It's going to what? Very first line. Attract to a substance. Iron, nickel, and cobalt are blank that magnets attract. So they're all, what are they? Are metals that all magnets attract. Steel is made with blank, so a magnet attracts paper clips. So steel. Steel is made with, what is it made with? Iron. So a magnet attracts paper clips, staples, and food cans made of steel. A magnet does not attract blank, 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 or blank. So let's look down here and see if we see it. Oops, I gotta zoom out for you guys. I think there was something. Oh, up top. A magnet does not attract to glass, plastic, wood, or rubber. So, does not attract to glass, plastic, wood, or rubber, which is a good thing because if electricity passes through it and our car's hit by electricity, guess what's going to happen? The rubber on our tires is what protects us. You can observe whether a substance, blank, or mixes evenly in water. So you can determine whether a substance, what's the substance going to do? It's going to, very first line of that second paragraph. What's it going to do? Dissolve mixtures evenly. In water, when materials dissolve, it blanks into tiny pieces and seems to disappear. So what happens when it mixes evenly? It breaks into tiny pieces that seem to disappear, right? So it blank into tiny pieces. I just kind of gave you the answer. It should be breaks into tiny pieces. Both sugar and blank dissolve in water. You remember? Both sugar and it's right there, that second paragraph. Look for the word both, sugar and salt dissolve in water. So the answer is salt. But many substances do not dissolve in water. On Earth, most matter exists as a, we have not gotten to that question yet. In Lesson 5, you will learn that water has different forms. On Earth, most matter exists as a solid, a liquid, or a gas. Each of these forms is a state of matter. which is another physical property you can observe. Heating or cooling matter can cause it to change from one state to another. For example, heating ice can make it melt. When ice melts, it changes from a solid to a liquid. You can learn more about changing the states of matter in Lesson 7. Let's see if we can answer anything here. On Earth, most matter exists as a... Right here, 3 properties. A solid, a liquid, or a gas. Each of these forms a blank, which is another physical property. Each of these form a, right there, it's in bold, state of matter. Which is another physical property you can observe. Heating or cooling matter can cause it to blank from one state to another. We can do that without even looking at it, right? If I'm going to heat or cool it, it's going to do what from one to another? It's going to change from one state to another. Heating or cooling matter can cause it to change from one thing to another. Scientists also use blank to describe many physical properties. Oh, we haven't gotten to that part yet. Scientists, right here, also use measurements to describe many physical properties. Temperature is a measure of how warm something is. You can use a thermometer to measure temperature. A common kind of thermometer has a liquid inside a thin glass tube that is marked with numbers. The liquid is usually red. When the liquid gets warmer, it takes up more space. This makes the liquid move higher in the tube. When the liquid gets cooler, it takes up less space. This makes the liquid move down on the tube. To find the temperature, read the number next to the top of the liquid. You can measure temperature in degrees Celsius or degrees Fahrenheit. Many thermometers show both temperature scales. Look at the thermometer to the right. It shows the temperature at 20 degrees Celsius, which is equal to 68 degrees Fahrenheit. These are different numbers for the same temperature. Okay. Scientists also use, very first line, measurements to describe physical properties. You can use a thermometer to measure. We're going to use a thermometer to measure, that one's easy, temperature, right? When the liquid in the thermometer gets blank, it takes up more space and moves higher in the tube. Well, if it's moving higher, it's going to get, when the liquid in the thermometer gets warmer, it takes up more space and moves higher in the tube. When the liquid gets cooler, it takes up, so if it's taking up more space when it's going up, it's going to take up less space when it moves down the tube. You can measure temperature in degrees of, what's C stand for? Celsius. Or degrees in the F stands for Fahrenheit. Mass is the amount of blank it makes up an object. We have not gotten to that part. Okay. Turn the page. Recall from lesson 3 that mass is the amount of matter that makes up an object. Units of measurement for mass include grams, kilograms. You can use a tool like this one shown. It's called a pan balance to measure the mass of an object.